Hey, hello and welcome to today's GFG problem of the day. Hope you're doing well. So let's see today's problem, rat in a maze problem. Okay, so what the problem is saying is there'll be a rat placed at 0th position. Okay, 0 in a square matrix of order n into n. It has to reach the destination at n minus 1, n minus 1. Find all possible paths that the rat can take to reach from the source to destination. Okay, okay, the directions in which the rat can move from source to destination. So what is the source? Source is this and destination is this, right? And what the problem is saying is we need to find all the possible paths. Okay, the directions in which the rat can move are up, down, left, and right. Okay, the rat can move either in up, right, left, right, or right, down, and left side. Okay, so these are the four directions the rat can move, and value 0 at a cell in the matrix represent that it is blocked and rat cannot move. So here, so like here, right, if the rat is at this position, the rat cannot move onto this position because it is 0. It can only move at positions at the cells which contain 1. Okay, so and rat cannot move to it while value 1 at a cell in the matrix represent that rat can travel through it. So that's what I said. In a path, no cell can be visited more than one time. Okay. So if the source cell is 0, the rat cannot move to any other cell. In that case, return an empty list. The driver will output -1 automatically. Okay. So here, so we have to, as you can see, right, we have to print or return all the possible paths, right? All the possible paths from the source to the destination, right? So there can be many possible paths. The rat can travel from this, right? From this side like this, right? This side, or it can travel this side like this, right? So there can be multiple paths, right? There can be multiple paths and we want to return all those paths. Okay. So this is what the ask is. Okay. Now, if you see, right, it's a clear case of DFS, right? It's a clear case of DFS traversal because we have to go like there are four possible directions in which the rat can travel, right? So bottom, there are four like right, left, bottom, and top. Okay, so it will clear case of DFS. So let's quickly implement so you'll understand better. Okay, before implementing, I'll also request you to subscribe to my channel. Thank you so much. So let's quickly see. So what we're going to do first of all take is if n let's take the length of the matrix, right? We took first. I'll show you the Java code followed by C++. Okay. So okay. Now first of all, we'll check if mat of 0, 0, that is a source. If it itself is 0, right? Then there cannot be any answer. Okay. Then the rat cannot move to the destination. Okay. And if the destination, right? If the destination also itself is 0, then again there can be no path. Okay. So what we're going to do is will take a array list result, right? Let me take this result equal to new array list. Okay. And what we'll simply do in this case, they are saying to return to add minus, it will be -1. We can add -1 and we can send. Okay. We can return result. So this was the base case first of all. And then what we're going to do, we are going to make a traversal. We'll also take a boolean, a visited 2D matrix size of n into n by n. Okay, to check because we don't want to traverse the same cell again, right? We don't want to traverse the same cell again. Okay, so what we're going to take n of n, and by default it is going to be false, right? Now we'll run a DFS. We'll call a DFS function. So what we're going to pass, we'll first pass matrix, then we'll pass on the source I and j, right? The source position. Okay, and then what else we want to pass? We want to pass a visited, and we want to pass a matrix length, right? And one more thing, we want to pass, this will be the path, right? This will be the path. So we are taking a path, right? We want to keep track of the path. So we'll send path as well. Initially, it is going to be empty. Now we'll implement this DFS function. What DFS, right? What DFS, and we'll let us define this mat int I int j, right? And then what we have boolean visited int n and the string path. So this is a DFS function. Now, first of all, what is going to be, let's first quickly write the four directions, right? So the rat can travel into the four directions, right? So what the four directions it is going to be? Mat, first of all, we are going down I plus 1, right? We are incrementing the row, right? And we will keep the column as is. Okay. This will be the visited we are passing. We are passing the matrix length and path plus. What we are going to do? Path plus what they are saying for the down when it goes down, right? So it is capital D. So we'll keep it capital D here. So we'll have four calls, right? As the rat can move in four directions. So now it will go up, right? When it goes up, we'll add U to it. That is upper, right? Up. Then we'll keep this row I as is and we'll increment the column. So it is going to the right, right? So we'll have right here and then keep I again as is and we'll decrement the column. So it is going to be what? Left, right? It is going to be the left, right? So these are the 4 calls. Now let's write the base conditions, right? So what are the base conditions, right? The boundary conditions will write I equal to 0 if I is less than 0 or j is less than 0 or I has reached the like greater than equal to n or j if it greater than equal to n, right? Then in that case we'll simply return. There cannot, we'll just return. Okay. Else what other condition can be? If at some I and j, right? If it is 0, if it is 0, then we need to return. We cannot move ahead, right? Or if a certain position we have already visited that, we had already visited that, if it is true, right? If it is true, simply return again. Now another condition we'll write is if we have reached the destination, for example, j, right? If we have reached the destination n minus 1, then we will, what we'll do, we'll add this corresponding path. We have got some path, right? We are already adding, right? Path plus d plus path plus u, we are already adding. And finally we got, we have reached the destination. So we'll add the path to the result. Okay. And we'll return from here since we have found one path. Okay. We have found one path. And why we're not checking mat of I, j, like n minus 1, n minus 1 if it is 1. So here we have already checked, right? Here we have already checked. So that means when it has come here, so that means this will mat of I, j or n minus 1, n minus 1, it is going to be true or 1. Basically, it is going to be 1. Okay, so these base conditions are done. If if the given cell position, if it is 1, right? So in this case, what we are going to do, I, j, will mark it as true. We'll mark it as true. Okay. And finally, for example, for a given cell, when we had started from this particular cell, right? Let's say we had started from this particular cell, right? From source, right? We had started and we followed the one path. We followed one path, right? So what we're going to do once we reach a destination, once we reach the destination, okay, through this one path, okay, once we are done, when the stack unwinds, right? We'll also mark this visited as false. Why we are marking visited as false? Because we want to find other paths as well. We want to find other paths as well, right? So that is why we will make it false. You got it, right? So why are you doing that? Here, for example, from one path, we marked visited, right? We marked visited, sorry, not this path, for example, this path, right? We marked visited. And then once we reach the destination, and when we go back, we'll also keep on marking false because we want to traverse the other path. We want to find the other possible paths. Okay. So that is why we will mark them as visited as false. Okay. So this is a solution. Let's quickly return the result as well. Okay. So the result will contain all the possible paths. Okay. So let me compile this. Oh, okay. It is compiled successfully. Let's submit it. Yeah, the test cases seem to pass. Yes, they have passed. I hope you have got the solution. This was graph problem, DFS based. Okay, I hope you have got the solution. Please subscribe to my channel, like the video. Let's quickly see the C++ code as well, the corresponding C++ code. Okay, so here let's start with the path, right? It's same, right? So n, we take the matrix size. We are checking if the source and destination is 0. If they are, we'll simply add -1. Okay, so here is the resultant string. It's a vector type. Okay, and we are returning the result, right? And then what we are doing is we are n by n, we are having Boolean matrix. We have initialized with false. We are having this path. We are starting, we are passing 0, 0, the source positions, the cells, right? And we are returning result. So here we are checking the boundary conditions. If it matches, return, or if the corresponding cell, if it is 0, or if it is already visited, we'll return it from there. If we have reached a destination, add the particular path, add this corresponding path and return from here, and we'll find other paths as well. Okay, so here we are marking true. So we'll go up, down, left, right, everywhere. So once for a particular, once the stack unwinds, right? So we'll keep on again initial setting false for those particular positions, right, in order to find the other paths. Okay, so this is the solution. I hope you've got the solution. Thanks for watching. Please subscribe to my channel, like the video. Have a happy, healthy, and a great day. Thank you so much.